models, framework, and techniques. Abstract. Nowadays, big data lakes are prominent component of the emerging big data architecture. Basically, big data lakes are the natural evolution of the data warehousing system in the big data context and deal with the several requirements deriving from the well-known 3V nature of big data. Along with the emerging of the data lake research initiative, several issues appear such as big data lake models, big data lake frames, and big data lake techniques. In the line with this exciting research perspective, this paper proposes an overview of a state-of-the-art approach that are at the foundation of big data lake research and innovative open problems and issues which drive future research directions on advancing the big data lake research trend. Big data, big data lake, and big data representation, big data processing, big data analysis. Introduction. Big data lakes 1 to 5, for example 1 to 5, are the natural evolution of a data warehousing system, appear in the emerging trend known under the term big data, and basically big data lakes deal with the requirement to superimpose by the well-known 3V model of the big data, standing the 3V for volume, velocity, variety. Looking at the base definition, big data lakes can be intended as a sort of shared environment englobing multiple big data repository that are present, processed, and mined according to already consolidated big data technologies. The final goal of big data lake is that supporting advanced big data analytic procedures such as big data exploration, knowledge discovery over big data, ad hoc big data analytics, complex big data analytics, complex tool over big data, for example, OLAP, reports, dashboard, and etc. A leading characteristic of the big data lake model is just dealing with the variety, that is the heterogeneity of big data. Indeed, nowadays, modern large-scale organizations comprise several types of big data repositories, ranging from the text data to the spreadsheet data, from Web2 data to relational data, from social data to the sensor data, from streaming data to the real-time data, and so forth. This strong heterogeneity combined with the high volume and high rate of the modern big data makes the issue of the designing, implementing, and running an effective and efficient big data a critical challenge for next generation big data research. Technology-wise, several solutions that support big data lakes already exist. Among others, a classical architecture sees the big data lake built upon a standard Hadoop infrastructure, such that the big data of the target global repository are stored in the proprietary data cluster, and Hadoop software provides all necessary basic as well as advanced routine for representing, processing, managing, and supporting advanced analytics over such data. It's not possible to treat fundamental big data lake research problems without mentioning an essential property of the big data lakes. That is, what data scientists can do with modern big data lakes. Basically, big data lake must necessarily also support the visualization of big data Within a large-scale organization, we are supporting meaningful analytics procedure over big data stores in the big data lakes. For decision support purpose, for example, business social trend, epidemiology, evolution, and so forth. This special feature is now supported within big data lakes via very sophisticated techniques mainly inspired by machine learning and artificial intelligence solutions. Along with the emerging of the big data lake research initiative, several issues appear, so some among the most noticeable ones are following. Big data lake models. How big data presented within a big data lake. And a big data lake framework, which are the most effective architectural solution for creating an efficient big data lake. Big data lake techniques. How to effectively and efficiently integrating multiple heterogeneous big data repositories into a big data lake. How to effectively and efficiently querying big data within a big data lake. These challenging questions have inspired this paper. In order to face off these latter, in this paper, we provide an overview of state-of-the-art approaches that are at the foundation of big data lake research, especially those that try to answer these challenging questions and innovative open problems and issues, which drive future research directions on advancing the big data lake research trend. 자, Big Data Lakes, state-of-the-art research proposal. Recently, several proposals appeared in the context of big data lake research under the three research axes introduced in section 1, that is, model, frameworks, and techniques. In this section, we provide an overview of the most relevant ones. 4. Reviews the definition of the popularity of big data lakes in the modern big data era. Most precisely, authors recognize that the concept of the data lake is emerging as a popular way to organize and build the next generation of systems to master new big data challenges. Nevertheless, there are lots of concerns and questions for large enterprises to implement data lakes. Within this line of research, the paper discusses the concept of data lakes and shares the author's thought and practice of data lake. 5. Still focuses on the fundamental of the big data lakes and related research issues. In particular, authors stated that at today we witness of the appearance of two additional to big data concepts, data lake and the fast data. Are they simply new marketing labels for old big data terms, or really new ones? Thus, the key goal of the paper is to identify the relationship between these three concepts. 2. Consider a real-life application of big data lakes, particularly in the context of architecture for supporting personalized healthcare service recommendation. Authors identify that personalized healthcare services utilize the relational patient data and the big data analytics to tailor the medication recommendation. However, most of the healthcare data are in the unstructured form and consume a lot of time and effort to pull them into rational form. This paper proposes another data lake architecture to reduce the data ingestion time and improve the precision of health data analytics. It also removed the data silo and enhanced the analytics by allowing the connectivity to the third-party data provider. such as a clinical lab research result and chemistry industry company. The data lake architecture uses the Hadoop distributed file system HDFS to provide storage for both structured and unstructured data, and K-means clustering algorithm find patient clusters with similar healthcare condition. Finally, it employs a super vector machine SVM to find the most successful healthcare recommendation for each cluster. Experimental results demonstrate the ability to data lake to reduce the time for ingesting data from various data vendors regardless of each format. Similarly, 3 focuses on another interesting case, the emerging static grids. Indeed, the author recognized that the advanced the time in smart degree agrees enabling huge amount of data to be aggregated and analyzed for various smart grid applications. However, the traditional smart grid data management system cannot scale and provide a sufficient storage and processing capability. To address these challenges, this paper presents a smart grid data ecosystem based on the state-of-the-art Lambda architecture that is capable of performing the parallel batch and real-time operation of distribution data. Furthermore, the presented ecosystem utilization Hadoop big data lake to store the various types of the smart grid data, including smart meter, images, and the video data. An implementation of the smart grid of big data ecosystem on a cloud computing platform is presented to test the capability of the presented ecosystem. Real-time visualization and data mining applications were performed on a real smart grid data. The result of those applications on top of the ecosystem suggests that it is capable of performing numerous smart grid big data analytics. 1. Introduce Azure Data Lake Store ADLS, a fully managed and elastic, scalable, and secure file system that supports HDFS and Microsoft Cosmos file system semantics. It is specifically designed and optimized for a broad spectrum of big data analytics that depends on the very high degree of the parallelism rights as well as the co-location of the compute and data for high bandwidth and low latency access. It brings together key components that are features of the Cosmos file system long used by the internal customers and Microsoft and HDFS, and is a unified storage solution for analytics on Azure and internal and external workloads on this unified platform. Distinguishing aspects of the ADSL include its design for handling multiple storage tiers, exabyte scaling, and comprehensive security and data sharing features. Summarizing the paper presents the overview of ADSL architecture, design point, and performance. The instead presented the Hydria, an online data lake that allows users without any information technology background to harvest, store, organize, analyze, and share heterogeneous, multifaceted cultural heritage data. Hydria provides zero administration, zero cost integrated framework that enables researchers, museum curators, and other stakeholders within the cultural heritage domain to easier deploy the data acquisition service like a social media scraper focuses on a web scroller, dataset imports, and question reform. Design and manage versatile customizable data stores, share a whole dataset or horizontal vertical data shared with the other stakeholder. The search and filter and analyze data via expressive yet simple to use graphical query engine and visualization tool and perform user management and access control operation on the stored data. According to the author-based knowledge, this is the first solution in the literature that focuses on collecting, managing, analyzing, and sharing diverse, multifaceted data in the cultural heritage domain and targets users without an IT background. Finally, 28 consider the maintenance issues of the big data lakes. Authors recognize that actually data lakes there's a large repository of low data sets from a disparate sources. As more data sets are ingested into there is an increasing need for efficiency techniques to profile them and to detect the relationship among their schemata and commonly known as the holistic schema matching. Schema matching detected similarity between the information stored in the dataset to support information discovery and retrieval. Currently, that is computationally expensive with the volume of the state-of-the-art DLs. To handle this challenge, authors propose a novel early pruning approach to improve efficiency, where different types of content metadata and schema metadata about the datasets are collected. And these metadata are used in early pruning steps to pre-filter the schema matching the comparison. This involves the computing proximity between the dataset based on their metadata, discovering their relationships based on overall proximities, and proposing the similar datasets to pair for the schema matching. Authors further improved the effectiveness of this task by introducing a supervised mining approach for effectively detecting similar datasets that are proposed for further schema matching. Extensive experiments on real-world data proved the success of the proposed approach in effectively detecting similar datasets for schema matching, with recall rates of more than 85% and efficiency improvement of above 70% are presented. 3. Big data lakes, research challenges and directions. A plethora of research challenges and directions in the context of the big data lake under axiomatic vision proposed in this paper exist. In the following, we report and discuss some noticeable ones. Big data lake architectures. Just like the ancestor data warehousing system, designing and implementing the effective and efficient big data lakes is just a problem. Indeed, the same architectural design of every big data lake heavily influences the effectiveness and the efficiency of the big data lake itself. Therefore, a first important big data lake research open issue is represented by architectural paradigm for a big data lake design, which must mandatorily evolve from the early data warehousing system design experiences. Modern data population alimentation paradigms for big data lake. Data population elimination process is a fundamental component of the classical data warehousing system. This governs how the input data sources are imported within the general scope of the major ETL, instruction transformation loading process. From the data sources layer to the data storage layer of those targeted warehouse system, nevertheless, how to replicate these models with big data lake. The three-way nature of the input big data makes it hard to be applied just as it is, like also highlighted by the recent studies. Here, novel solutions are mandatory. Among others, the sampling-based approach seems to be a nice initiative forces. The query rewriting paradigm for big data lakes. Big data lakes tend to keep the big data repositories ingested within their core layer in a kind of RAGE integration where these repositories are kept in their original form. The lacking effect is obtained via schema mapping methodology and, most important, query rewriting techniques. Designing the device effective and efficient query rewriting techniques for the core layer of the data lake is without a doubt one of the most challenging issues of the future big data lake research. The modern metadata measure for big data lakes. Metadata management with the big data lake play a critical role, even more relevant than a corresponding functionality of the ancestor data warehousing systems. Indeed, due to the 3V nature of the big data, first essential the procedure to be supported with a big data like is a big data exploration. Due to the complexity of the standard big data lake architectures, the key of the success for the supporting effective and efficiency big data exploration is just represented by effective meta manager design and implementation for big data lakes. Simply, classical approaches are not effective of modern big data lake applications scenario, and therefore the no need to the innovative and modern metadata manager design and implementation paradigm study strictly arises. Machine learning tools over big data lakes are distinctive characteristics of the big data lake is support for machine learning tools that are frontier layers. This meant for final supporting the value extraction from core big data repository to be used for knowledge discovery and decision-making process. Across the years, a relevant number of machine learning tools has been proposed in the literature. Unfortunately, these adapt a basis low input data model, which barely copes with the modern features of the big data repository. As a consequence, designing effectiveness efficiency machine learning tools to be implemented in the front end of the big data lakes become one of the most relevant challenges to face off, even due to the each comes in a plethora of real-life big data application ranging from healthcare analytics to the social solution analysis tools, from the smart city applications to e-science solutions and so forth. Big data governance methodology via big data lakes. Data governance refers to a collection of models, methodology, and paradigm for supporting a so-called data-driven digital society. That is a futuristic vision of according to which the main societal processes, for example, demography, citizen services, public administration, and so forth, should be driven by analysis of historical and real current data used in terms of decision-making pillar. Indeed, nowadays, a clear case of the adherence to this vision is already evident. The COVID-19 pandemic outbreak and the policies that countries are trying to limit the phenomenon being these policies totally driven by the daily analysis of the the outbreak evolution. A big data lakes the answer to the final support for real big data governance for next generation societal challenges. This question identifies a critical matter that a future research effort must take into account. The privacy preserving big data lakes. Contrary to the ancestor data warehousing architecture, where the privacy pregnancy data management problem has been poorly addressed for a counter period, privacy reservation for big data lakes play a critical role due to the fact that usually big data applications deal with sensitive data and, for example, social data, sensor data, biomedical data, healthcare data, and so forth. From this clear evidence, it follows new really achieving so-called privacy-preserving big data lakes That is a big data lake architectures where all the core procedure and a data population, query rewriting the metadata management and so forth, are designed and realized according to the privacy preservation data management paradigm. According to our division, the latter is among the more relevant critical challenges for future generation big data lake research. Emerging big data lake application. Last but the least, it is worth to noticing noticing that the big data lakes are the physical architecture such that a real-life application induce in a continuous improvement of the architectural component via iterative tuning and update dictated by realistic metrics. For example, temporal complexity of the big data access and query procedure, accuracy of big data analytic for front-end tools and used usability and so forth. Therefore, the modern application scenarios such as smart cities in government, healthcare management, energy consumption system, and so forth will be more and more beneficial for evolution of big data lake architectures time by time. The research challenges thus consist of learning effective lessons from authoritative case studies to found the big data lake architecture from practice to theory. For conclusion, inspired by trend that focus that one big data lake models, frameworks, and techniques in this paper, we have explored the actually challenging of the big data lakes and provided some future research directions in the investigation scientific field. The most evident conclusion of our work consists in the recognize that there is still a lot of research to conducted in this area. We hope this paper will be present another useful milestone to this end. For instance, in the idea exploiting data semantics, perhaps inspired by a similar research experiences, seems to be a promising the direction for the further improving the effectiveness and the efficiency of big data lake processing. Okay, thank you.